for answering a very simple, caught a giant bit of flack for that, but yeah. All right, for part A. Come on, really? For part A. What's the answer?
It's all.
Yeah, they're all the same. They were all immediately removed from 100 degrees Celsius water. So what would be their temperature? 100 Celsius, right? It's all the same. Does that make sense to everyone? Now that I've been totally condescending and insulting, like someone's going to ask. Okay, well, if you'd like to ask, feel free to talk to me afterwards, and you can call me a mean name or something. Make sure which blocks undergo the same change in temperature? For part B. Now, does it make sense to you that when all of these things get finished, when you just leave it there until they all equilibrate, what will also be true about all of their temperatures? Yeah, it's all are going to be the same again. So all of them are going to be this. They're going to have the same change in temperature because they're going to start at 100 and they're going to drop down to the same level. I mean, does that make sense to you? Because think about the other possibility. The other possibility is that in 30-degree water, you've got iron at 40 and aluminum at 10. What? No, that doesn't make sense. Okay, not just because none of them are 10, but you get the idea. Then C, which blocks have approximately the same amount of heat transferred to or from them? Okay, I'm not sure what the specific heat of aluminum. Well, we know that the specific 100 kilogram. What is the specific heat of iron? It's in the chapter because there's a table. What's it? 450? Okay, so the specific heat of iron, CFE, is 450 joules per kilogram Celsius degree. So for part C, do you see that block A and block C are about the same? Because block C has half the mass, but it has twice the specific heat. Right? And since Q equals mc delta T, if they have the same change in temperature, then the differences in mass and specific heat cancel out. Part D, which blocks arrive at the same final temperature? All.
So B and D are the same.
Yeah. So it's they all start at the same temperature, they all have the same change in temperature, and they all arrive at the same final temperature.
But wouldn't certain metals like cool